Hello, today's puzzle tests our knowledge about storage slots in Solidity. So let's jump into the smart contract, in which you can see some initial variables and also one essential function, which is unlock, which we'll have to trigger successfully passing the right key, which is basically a password. And we can see that the proper password is stored in the data array, and then it's parsed to bytes 16. So whatever we pass has to equal to bytes 16 of the third object, because we start from 0, of this bytes 32 array. So we can immediately see that we are parsing bytes 32 to bytes 16. But also that this variable is private. But I think that a few puzzles ago we learned that all the variables in Solidity are not truly private, and if we are competent enough, we can access them easily using the console with Web3. So knowing that we can access the right password from the private storage slot, although we have to use the web3.if.getStorage at function, and we have to pass the instance and the slot we want to access. So often you would just pass the number of the variable that we have here. So if it's here, you would pass like 0, 1, 2, 3, 4, 5. Maybe if you are more insightful, you would take into the account that you have 3 variables here. So you go to 6 and 7. But the problem is that in Solidity storage slots, they are made so that they try to compact as many variables as possible. And one storage slot takes like 256 bits. So it's 32 bytes. And this way, if we calculate how many storage slots we have, we would have to go like this. We start with Boolean, it's 8 bits, so it takes 1 slot. Can we fit anything else into the slot? Yeah, we can. But can we fit 256 bits? No, we can't, because this one needs like the whole slot for itself. So that's the first slot. This is the second slot. But then you can see that we have 8, 8, 16 bits, so smaller variables, and we can easily fit them into the 256 bytes slot. So they will be stored in the same slot number 2. It's 0, 1, 2. And can we fit this thing? Well, it's 32 bytes, not bits. As the name suggests, it's about bytes here. And 32 bytes is 256 bits. So essentially, we have 3 variables in this array. So each of them needs a separate slot. So we have slot number 1, slot number 2, slot number 3, 4, 5, and 6, right? Or 0, 1, 2, 3, 4, 5. Yeah, I started from 1 and it starts from 0. And if we were to move this Boolean down below the uint 256, we could easily fit it into this slot and optimize it a bit, use 1 slot less. But in this case, we have to access the last variable from this array, because it starts from 0, so 0, 1, 2 is the last one. So we have to access the private data value, and to do that we pass the right slot, which is the 0, 1, 2, 3, 4, 5. And add await because that's a promise. And you can see that it returns the value stored in this slot. So knowing that, I think that we can move to the implementation part and think about parsing its to bytes 16.
So going for the implementation, what we want to do now is to get through the function unlock. We want to pass the key, but as you can see, the key is in the bytes 16. So we have a problem because our hex is in the full and it's a half of the hex number. So what we want to do is to get the half of the hex. How to do it? Simply by getting through the slice option. So let's copy the hex number, get through the slice with the arguments from 0 to 34. Those arguments, because all digits are 66, and if we will minus 0x from the beginning of the hex number, we'll have 64, and half of that is 32. So 32 plus 2, it's 34. So that's why we want to go through arguments 0 to 34. Our solution we can copy and use for the function unlock. So how to call that? Simply await construct unlock and just paste in the string the number. Let's check if it's viable. All right, try to submit instance. Great, here we are. Okay, thank you guys for watching. Leave a like, subscribe, comment if you got any problems. See you in the next video.